Hello, good afternoon, good evening, good morning to everyone who is watching us live, or maybe will be watching this recording on our YouTube channel. I would like to welcome you on our next TWF meetup, in where we share news and informations about our newest technologies. And today with us is Paweł Grudzień, who will
Hi.
tell us more about how you can transform an old phone to be a little bit more modern. Hello, Paweł. How are you? Can you tell us a little bit more about your today's subject?
Yeah, sure. Hi. Thank you, David, for inviting me here, and welcome everybody on the YouTube channel, either here or later. My name is Paweł Grodzień. As you already know, I'm working with Avanade for about a couple of years right now, but I have over a decade of experience in IT. I'm working as an AI engineer. Um, well, a little disclosure here. I don't have much experience with electronics, but just this project is very much about my hobby, which is joining these two worlds, the electronics and programming world, where I have a lot of experience. So yeah, this is definitely about my latest creation, which is the retrophone, as David said, and yeah, let's go on with that.
All
Rock and
right.
roll.
So the stage is yours. I will give you the floor. Good
All
luck,
right.
and I'm waiting to hear more.
All right, perfect. So let's start over here. So I think we all agree that electronics and the IT field are very exciting, and the intersection between them is where the magic stuff often happens, and this is where the microcontroller world actually starts for me, and this is the place where I my hobby and a lot of my personal time goes. So actually, what is a microcontroller? You could ask. Uh, David, tell me if the presentation is visible.
Yes, it is. It is.
All right, perfect. So let's start with microcontrollers. So a microcontroller is a very small chip that you can program. The very basic entry microcontroller that everybody knows and loves is Arduino. Arduino is great for small projects. This it has input output pins. It can control a lot of things, and it's suitable for a lot of basic projects. But when you need something more, well, your project demands more advanced features. This is where ESP32 may come in. So this is not I wouldn't say that this is a basic entry level microcontroller, but still definitely very approachable. Compared to Arduino, it has a lot more processing power and memory. For example, Arduino has this 40 megahertz processor, while ESP32 has up to 240, and it has even two cores. So you may ask yourself how to do programming on such such microcontroller when you have more than one core. The obvious response to that is to using some kind of operation system. In this project, we'll see some bits of free real-time operating system, free RTOS. ESP32, compared to Arduino, again, has a lot of connectivity features. It has built-in Bluetooth and Wi-Fi capabilities. It even has some support for connection via wires, so you can use Ethernet to connect to your network. It has a lot more capabilities if it comes to analog and digital input-output. Draws a little bit more power than Arduino, but you need to take into account that it has this Wi-Fi and Bluetooth module. So if you add this capability into Arduino, it may even out. Pricing-wise, I would say this is the same, more or less the same amount. Of course, Arduino is a bit cheaper, but ESP32 goes has a lot of more features, per dollar than Arduino. And well, all of these features actually convinced me to use it in my next project. And this one actually turns out to be this retro phone. I think that the heart and the most important thing in ESP32 is the software. ESP comes with this development framework, IoT development framework, IDF, which implements a lot of features and drivers. It comes with the kernel for the operating system, and you can use it to build your own projects based on like Bluetooth stack and Wi-Fi and all of that goodies. And well, this is on top. You can see on the top right hand side, this beauty is actually the development board for ESP32. Yeah, so if you haven't heard anything, if you haven't watched the previous video on the channel with the introduction, the short story about this project is that I went to talk with my friends on the pub, and we talked about things that we, as the oldies, we recognize and we used while we were children, but our children doesn't either recognize or haven't used. And one of them was the phones. We had these phones with rotary dial that you can see on the bottom. Some of you even may not had a chance to use it. But this one is something that my friend had, and she told me what exact model she had. This is it. This is the one, and what exact color. So I figured that it would be a perfect birthday gift for her incoming party. And I thought to myself back then, how hard can it be to add this modern features, add this ESP32, then make it work with Bluetooth capabilities and so on. So I had 2 weeks until the birthday, and here we are, 2 months after, over 2 months actually, right now, after her birthday party. And the project is almost complete with I would say some little bugs in the software, but generally I figured everything from the hardware part and 90% of the software part. So back to ESP32. I think this is let me show you actually how it works, because this is the heart of this project. So let me show you how you can start with ESP32. So basically, the idea for this project was to add ESP32 to the phone, and you could connect via Bluetooth through the phone and answer the phone. You could even dial to someone, ring a friend, and well, give him a talk. So let me switch to here. Okay. Yeah, and my well, the ESP32 comes with this development framework, as I said, and it has a ton of examples that you can use to learn ESP and the framework and how it's how to use it. Let me change the screen for you. No, this is okay. Okay, yeah, sorry for that. This is the one. And what we have here is the IDE. This is Visual Studio, and to start with ESP32, you need to download this one and install it as a extension to Visual Studio. And it comes with little features for building, flashing the chip, monitoring. This is a serial port for monitoring the messages from the device, and a set of others. One of them is the set of examples that you can start with simple projects. There's a Bluetooth ton of examples. Among others, there is this classic Bluetooth, and I was happy to see that there is this hands-free client here, which has like 80% of what we need to do for audio gateway and this connections to the smartphone. This is something that I used for the base for the phone. We can see that that there are really a ton of examples. There's a set of examples for Bluetooth low and low energy. I've seen somewhere here a mesh that you can do with ESP32. So connect a couple of them, and they will be connecting via a mesh Bluetooth. So that's something you can do, for example, with I don't know, maybe drones, or if you need to have very reliable communication between the modules. there is this Ethernet implementation over in the chip. There are a couple of other this stack implementation on top of it. There is also important for me, as it turned out, this I2S protocol, which I will explain later. This is for the sound. And again, LCDs, whatever you need, it's probably here. Touch sensors and well, protocols, even HTTP server. There's somewhere here. Storage, and you on top of that you can, of course, download third-party libraries to use it. Yeah, so when you set up the project, for me it went very smoothly. I just started the project and then chose the COM port from here, and well, from there, building and flashing, everything went very smoothly. So nothing to be afraid of, and I think that this is very comparable in terms of how hard it is to Arduino, and even better because we have Visual Studio here. If you're not too familiar with C programming, because this ISP IDF requires you to do, you can use other languages. Among others, there is Python binding, Java binding, and even C# binding. There is a community around this one. I've looked at it, and it actually has extension to full Visual Studio. It looks very nice and promising. You can use packages, download it via NuGet, and it's awesome. I chose to do it in C, and I have a couple of tests, and from now on I think that we'll dive a little bit deeper on how to make it work with the phone. But before that, I want to show you what exactly I want to achieve. So this is on the left-hand side. You can see the that screen is a bit smaller than I would like. And generally, this phone has this ESP32 already connected, and you can search for look for this ESP Bluetooth device here connected, and it just works out of the box. That was very surprising, and something that really actually surprised me, that such seemingly hard thing to do is achievable with just a few steps. Yeah. Another thing that's well, maybe let's talk about for a minute what this example of hands-free didn't have. So it obviously didn't have the implementation of the things like a cradle or a bell of a real phone, and it didn't have even the sound implementation. So what it was doing is it was just transferring what came in to the output, and that's it. So this one actually took me a while, and this is the I think that the reason why it took much longer than expected, and I didn't finish that in the project in 2 weeks. So what happened is that the output of the sound is usually made with well, 2 connections to the speaker, right? This one I figured out quite quickly, how to connect the ends of the cable to the speaker. But it turned out also that that the microphone is a little bit harder, because separately the microphone and separately the speaker were working quite okay. I was able to record and separately to output something on the speaker. But they have in the inner workings of ESP, they have like a common part, this DAC, that means which is used to convert digital into audio signal, digital audio converter, and audio to digital converter, which is used to convert the sound from the microphone. Actually, they both use the direct memory access in the chip itself. And sadly, after a week of trying, I figured that they are using this common part, and they will not work together at all. Never ever. I mean, not in this version at least. So what I had to do is do a little bit of compromise, and this is, I think, the only compromise that I needed to do. I needed to buy a microphone that is a digital microphone in its essence, and this is the one that you can see on the top. It transfers the sound via I2S protocol, which is, well, the simplest protocol for sound you can imagine. But it still uses 5 wires. This wire here on the phone consists only 3 wires, so I couldn't put it back into the phone, right, inside. And the compromise is to put this microphone like directly into the box. But I believe that it will work somehow okay. It's like hands-free with loudspeaker, I could say. Yeah, so that was the hard part, and I thought that that the next parts will go a bit smoother, and I wasn't wrong about it too much, at least. There were a couple of other things to do. So this rotary dial mechanism I figured quite quickly. It has 3 wires, the red, the yellow, and the green. And this rotary dial mechanism actually works quite easy. I think I'm actually I'm amazed and full of respect to the engineers that got it working. So that they were always thinking about something the simplest thing that could work, and this works quite easily, and this is awesome. So there are 3 wires. The red wire is the connection wire to support the voltage, and yellow and green actually indicates what when user turns the dial. So yellow is responsible for it's usually connected directly to the red wire, and when you have voltage, it's normally connected. When you start to turn on the dial, then it loses the connection, and this is the time where you should look for the impulses on the phone, on the other wire. So I'm not sure if you can see that, but when you turn that, and yellow wire somewhere in the mechanism here loses the connection, but when I release the dial, it makes this pulses that we can see on the top, and this is basically how they count this this pulses. And this is how they originally sent it back to whatever device was responsible for ringing. I think that I had a demo here, or not. Well, so that was the rotary dial. I think that I can show you the code for that. Yeah, definitely. Rotary dial. That would be it. Yeah. So if we examine this one, this is quite easy, as everything here. So what it requires from us is, and I'm showing it to just to showcase you how easy is to program with this IDF. You just need to set up these GPIOs, which indicate on when to run a method, right? And when the device, when the ESP32 actually discovers that there is an edge. So this is very easy to do. You just need to configure the GPIO start task. This task, by the way, is a part of FreeRTOS operating system, and it runs in forever loop, right? And basically you add a handler for this enable pin and interrupt pin, which is my names for this longer and for the yellow and green wires, basically. And the code for that is like 150 lines of code, and it does really everything that's that you need to. Yeah, so I have this one for you. And again, sorry for if it's smaller than expected. Oh, we can do that, right? So yeah, this demo, what you can see here is how to use this IDF. On the right hand side, of course we have the same code, and what I do here is just click build, and it basically takes a few seconds to build it, flash it onto the device. It uploads the code, and click monitor. On the take note that I'm dialing the number here. Funny thing is that the muscle memory I had actually remembered my old phone number from my childhood to my home, basically. And yeah, I didn't even know that I do remember this one. The logs here, if we stop for a moment, like about here, tells that I finished the dialing number, and this is how I control the later the dialing number in the Bluetooth connection as well. Yeah, so that's that part. The cradle is a switch with also very basic and awesome design. What you see here on the picture is a switch, and when you press that cradle here, it pushes this top white element, which in turn pushes this metal parts. Then they come apart, and the switch loses the connection between the metal parts, and you can see that there is three of them. I guess that it would be enough to make only one, but what they did is actually awesome for me. That it's not gonna wear that much, and I'm guessing that this is kind of a solution to what happens electrically. So when you turn off or on the switch, the electrons between on the switch actually jumps back and forth, and what you get electrically is not straight 1 or 0, but there is a short period of time where you get like a mess. And what they have here is somehow controlling this effect to the point where it's not that visible. So and I have like an animation of how it works. Let me show you here, right? So this is how it works. For me, it's fascinating how they designed all of these small elements in this phone. This is, of course, has this shell on top of it, so that it's not like falling apart. I took off this shell to show you how it works, so that you don't have to do that for yourself. I find it awesome. Yeah, so this is how the switch works on the phone, and this is the same very much. Let me switch the window for a second. Yeah, this one. And let's together examine the code. This is even easier than the previous one. One thing that is, I think, important when you learn electronics, and this is something that I had to learn myself, is that concept of pull up and pull down resistor, which fortunately ESP32 has this pull up and pull down resistor built into the chip on almost every pin, compared to Arduino, where you usually have one or two, I think, pins that has this programmable pull up, pull down resistors. And what it does, oh, maybe I switch for you here for a second to my design of the electric board, PCB. And here we can see the connections. One, this breaker here, one pin connects to the ground, and the other one is connected to fourth pin of the ESP32. So what happens if this these two pins? Let's imagine that between the first and the second pin here is the switch. So what happens if it's turned off? If it doesn't have the connection? And this pin, actually, what it reads, what it might read is a null value if we compare it to the programming world. Instead of like the true or false, or 1 or 0, it gets like a null value, or a series of ones and then zeros and all of that mess. So the electrical solution to this problem is that you would usually connect this pin to high value of a voltage, and this way this pin, usually when it's open, the switch, this pin reads once, and when you close the switch, then the electrons goes to the ground, and the microcontroller here can read 0. Well, you could do that with additional resistor to connect to high voltage, but what happens is you actually can do that directly from the code, and this is another thing that I think is awesome about this this microcontroller. That really is packed with such features, and you don't have to worry about small things. So again, here, configuration of the GPIO, and just add a handler which reads the state of the cradle, and that's basically it. 50 lines of code with all the loggings, and it even includes the some headers. Right. So let's move on here. Well, not this one. Sorry. We were at the cradle. And the last thing that well, left is the bell. The bell is a funny one because the bell, what it how it worked back in the day, um, is that there was a separate line with AC voltage. Uh, that is, it had a sine wave, and when the central device, I mean that someone was calling you, this signal, this AC signal was transferred directly into your phone, and it's like switched on and back. This electromagnet here, which in turn made a force on this head that was, well, ringing basically. And I had to mimic somehow this AC. I obviously don't have the AC voltage anywhere here because all the microcontroller works on DC. So I was thinking, oh, what can I do? That's gonna be a challenge. I was thinking that I could even somehow make digital to audio signal and do some wave out there connected to the to some amplifier and then do the ringing. That was my initial idea. I know that some of you may have some experience with electronics, but I really don't have, and I would be grateful if on the comments down below you could type in some of the well, maybe ideas how to solve it. But after some thinking, I had an idea to use because I was thinking that this is, I don't really need this wave to be like continuous. I could use a square wave to do the same job, and it's brought me to the idea of using a simple motor controller that usually I use for DC motors. And what it can do is to reverse the polarity of DC and run the motor like backwards. So I figured that if I could use this one and supply it to the bell, then it would work. And then I had a couple of days thinking how to do that, because it wasn't working, and it turned out that actually I needed a higher voltage. So I added another component to this one, and instead of 5 volts, I'm using here 7.5, and it's working perfectly. What I had to do also is to choose correct value for the well, basically how fast this is switching, and on the top you can see the output of the values. You can see that they are interchanging when the top is top signal is high, the bottom signal is low, and they interchange, right? So this comes to the well, maybe I'll put it this way. For the bell, it looks like it looks like a wave, right? So it has tops and bottoms, and this is all working because it pushes this head in the correct way. And this was my solution. I was actually very proud of this. Well, and maybe there is a simpler solution. I could really use some help here. Yeah, and the last part actually of this project was to after I figured that I'm not gonna make it on time. I decided to make my own PCB board. This is something that you should not do. I'm not this is not something that I would repeat, but I spent nearly 2 months. I actually did enjoy the process, but if you don't want to spend like 2 months of your life just making a PCB board using 3D printer, then then it's not something for you. But if you do, and you do enjoy the process, then of figuring out all the small things, and you will come up with a beauty, something like on the picture here. And this is something that I used this 3D printer with CNC capabilities. This is for like drilling and cutting. I had painted the copper side of the board, and then use a laser to remove the paint only on the places where I didn't want the copper to be, and then use a solvent to remove the copper and so on. So this was actually a very long process to make it work and to adjust all the small things that didn't go well. Yeah, so and here we are again. This took me 2 months of my time, and I can answer your questions if you have any. For now, it's the end. Do you have any questions?
Hi, Pavel. I don't see any questions on the comments, but I probably have some. First of all, thank you for the presentation. It was really great and interesting. And for me, even I do remember those phones, and I was still using them. It was really interesting to see how they worked, like under this old plastic cover.
Yeah.
So it was really a lot of news for me and
All right.
information. And I would like to ask for sure, because you told us on the preview, this project started from just conversation with the friends.
Yeah.
And there were a lot of challenges you mentioned. There was a really lot of steps you need to solve and overcome, both from programming side and electronic side. And can you share with us where you were searching for this information, where you were finding it? Maybe you have some, I don't know, sources for someone who would like to, learn more or go deeper with this?
Yeah, for sure. We have definitely for the programming side for ESP32. We can share the link to the documentation. This is a great place to start. And well, this is all you need from the microcontroller side. From the electronic side, there is definitely this learning curve that you need to where you need to put your own effort to learn this very basics, at least to figure out how to wire everything. If it's well, for the inner workings of this phone, well, I have to say that I didn't have any materials myself, so it was like figuring everything step by step. It wasn't that hard because I have already some workshop over here near my bed, and over the night I was able to figure one thing after another. PCB, as I said, it's better to use some external services, third party, than to do it yourself. But if anyone's interested, I'm planning to release some notes on this one on my GitHub. We may share the code for the phone after the presentation, maybe below on the comments of the YouTube channel. If anyone's interested how it goes, and well, maybe replicate the project. Or even do something better, because there are some improvements that we can do. For example, we can do some diodes here, replace this one. I was thinking about replacing this one with some display, and display, for example, the number of the person who is calling. That would be, I think, awesome to see on this phone, and especially when where, well, there isn't such modern feature here. Like that would be an extension. I think that would be great. And yeah, for the PCB, don't do that. but if you really do, then you can take a look at my notes. I mean, yeah.
All right, so for sure we'll share your GitHub and notes with our audience. So thank you once more for your time and very interesting subject. Thank you all for watching, and I would like to remind you, if you would like to be on the other side with us as Pavel, and you would like to share some interesting stories or facts or updates, you can always reach us on our TWF meetup. There is short form to fill, and we will contact with you. And yes, if you are willing to hear about any updates or new webinars coming, new meetups, you can always follow us as well on LinkedIn or on Facebook or on YouTube. So thank you, everyone. Thank you, Pavel, once again, and have a great afternoon.
Thank you, David.